Hi again, this is Reverend Greg, and I would like to continue now with the introduction video to GLSL shaders for hobby programmers in GameMaker Studio. The last technical part of this introduction is about using the vector data types in GLSL because they are really important and used within every single shader you'll ever write. First, look at how to read vector components. I think I mentioned at the beginning that the vectors can be seen as array, and they can actually be used like arrays. So to get the values of a vec4, like the varying vector color, you could write this: float v1 is vv color 0, float v2 is vv color 1, float v3 is vv color 2, float v4 is vv color 3. Just like arrays. But you can also use letters. In example, float red is vvcolor.r, and float green is vvcolor.g, float blue is vvcolor.b, and float alpha is vvcolor.a. Or with the varying vector text code, float xx is vvtextchord.x, and float yy is vvtextchord.y. The other two letters in that row would be z and w, by the way, so x, y, z, and w. And there's a third set of letters you can use, s, t, p, and q. Those you'll sometimes see instead of x, y, z, and w to refer to texture coordinates, but I've rarely encountered or used those. Technically, you could write float v1 is vvcolor x instead of float v1 is vvcolor r. So you don't have to use RGBA for colors or x, y, z, w and s, t, p, q for texture coordinates, but it does make sense to use the different sets since it really helps with reading the code. Interesting about using those letters is that GLSL allows to use multiple letters on the same variable. So let's say you want just the RGB values of the vec4 varying vector color. You could do this like so. vec3 base color equals vvcolor.rgb. So vvcolor.r returns a float, but vvcolor.rg returns a vector 2, and vvcolor.rgb returns a vector 3. If for some reason you would like to swap r with b, you could write basecol.rgb equals basecol.bgr, or even basecol.bgr equals basecol.xyz. This is called swizzling, and both versions would just swap the red channel with the blue channel. What you cannot do, however, is mix the sets. Basecolor.bgr equals basecolor.ryp will not compile. It will have to be .xyz or .rgb or .stp. Now let's look at constructing vectors. To construct a vector, you just write the data type and after that in brackets the floats you want to create the vector from. So if you, for example, want to create a yellow color, you could write vec3 yellow equals vec3 1.0 1.0 0.0. If all the components are the same, it's enough to just write 1. So white could be written as vec3 colon 1 equals vec3 1.0. And you can build vectors from smaller vectors and floats. vec4 col 2 equals vec4 col 1 0.5. This will result in a vector 4 with the components 1, 1, 1.5. Here we construct a vec4 from a vec3 and a float. Or from two vectors actually. vec4 color 1 equals vec4 0.6, 0.8, 0.4, 1.0. vec4 color 2 equals vec4 0.1, 0.2, 0.3, 0.5. vec4 color 3 equals vec4 color1.rg color2.ba becomes a vec4 0.6, 0.8, 0.3, 0.5. So here we construct a vector 4 from two vector 2's. Or even like this, float AA equals 0.5. vec3 col1 equals vec3 1.0. vec4 col2 equals vec4 color1.rg 0.2 AA. And that results in a vector 4 with 1, 1, 0.2, 0.5. So here we construct a vector 4 from a vector 2 and two floats. Even swizzling when constructing a vector is allowed. Vector 3 col1 equals vector 3 0.1, 0.2, 0.3. Vector 4 col2 equals vector 4 col1 GBR 1.0, which results in a vector 4 with 0.2, 0.3, 0.1, and 1.0. Here we swizzle all three color channels R, G, and B, set alpha to 1, and then construct the whole thing as a vector 4. A side note on constructing something else than a vector. If you got an integer and need to calculate it with a float, in example multiplying it, you can and have to construct the float. This will not work. Float f is 0.5, int I is 2, float result is f times I, because you cannot multiply a float by an integer, but you can construct a float from an integer like so. Float f is 0.5, int I is 2, float result equals f times float I. Now we constructed a float from the integer and the code works again. Next, let's see how operations with vectors can be done in GLSL. It's really amazing how simple it is. Adding or subtracting vectors would be written like so. vec2 dir1 equals vec2 1, 2. vec2 dir2 equals vec2 0.5, 0.2. vec2 dir3 equals dir1 plus dir2. The result is actually pretty simple. It's vec2. The first component is 1 plus 0.5. That's the two first components of dir1 and dir2. And the second component will be 2 plus 0.2, which are the second components of dir1 and dir2, resulting in a vector 2 with the components 1.5 and 2.2. Since dir1 and dir2 are both vec2s, as is dir3, we don't even have to use a constructor. So we don't have to write vec2 dir3 equals vec2 dir1 plus dir2. We can just write it without the constructor vec2. Now if you add or subtract a float to or from a vector, that float is added or subtracted from each component of the vector. So vec2 dir1 is vec2 1 and 4, float f is 2, vec2 dir2 equals dir1 minus f, and that results in a vec2. The first component is 1 minus 2, the first component of dir1 minus the float 2. The second component will be 4 minus 2, that's the second component of dir1 and subtracting the float 2, resulting in a vector minus 1, 2. So we don't need a constructor for f either. It's automatically subtracted from dir1 x and dir1 y, and the result still is a vector 2. And multiplying and dividing component-wise in GLSL works pretty much the same as adding and subtracting. vec2 dir 1 is vec2, 1, 2. Vec2 dir 2 is vec2, 0.5, 0.2. Vec2 dir 3 is dir 1 times dir 2. What this does is multiplying the first component of dir 1 with the first component of dir 2, 1 times 0.5, and multiplying the second component of dir 1 with the second component of dir 2. So 2 times 0.2, which results in a vector 0.5, 0.4. Again, we don't need a constructor because dir 1 times dir 2 results in a vec2 anyways. And if you multiply or divide a vector with or by a float, each component is multiplied or divided by that float. So vec2 dir 1 is vec2, 1, 4. Float f is 2. Float 2 dir 2 equals dir 1 divided by f. So what happens is the first component of dir 1 is divided by the float f, and the second component of dir 1 is also divided by the float f, resulting in vec2, 0.5, 2.0. And here again, we won't need a constructor because f is automatically dividing dir 1x and dir 1y, and so the result is a vec2 again. If you don't want to multiply component-wise, but create the dot product or cross product instead, you can use the functions dot and cross. Now you should hopefully have some basic idea of how GPUs work, and this will hopefully greatly help to understand the shaders we're going to build. Before I end this introduction, I'd like to mention some helpers you can use. First, there's a really neat reference card you can print and keep close when working with shaders. Then there's the specification and a great documentation on Shaderific. And last but not least, cheat sheet on vectors I made for myself. I'll put all the links down in the description beneath this video. I know that was a lot to digest. I hope you're not too bored to continue with this series, because next time we'll start with the first shaders and we'll build on that knowledge from video to ever more interesting stuff. I'll try to release a video once a week or so, but I'm not absolutely sure if I can manage that. If you want to get an automatic notification when I release a new video, just subscribe and click the notification bell. I'm okay if you don't. I don't care about the numbers of subscribers and won't monetize this channel anyways. It's just me giving something back to the awesome GameMaker community. Until next time.